So this is the beginning of Chapter 3, Matter and Energy. And of course, if we're going to study chemistry, we're going to be studying matter. We ought to have a definition for what matter is. And matter is anything that has mass and takes up space. Examples of matter would be anything that has mass and takes up space. How about a book, an apple, a cat, the desk? What's more interesting to me, I always ask my classes, what are examples of not matter? Well, things that are not matter are things like light is not matter. Energy is not matter. Heat, not matter. And gravity is not matter. Okay, so let's divide matter up into pure and mixtures. So this is the beginning of our chart. It's all matter. And all matter can be divided into pure substances and mixtures. Pure substances can then further be divided into elements and compounds. Elements can all be found on the periodic table. So we always know which things are elements. If it's not on the periodic table, it's not an element. Compounds are two or more elements that are chemically combined. More elements that are chemically combined. And we can always see them as, they'll have formulas. And they'll always have the same ratios. Water always has 2 hydrogens for every 1 oxygen. Carbon dioxide always has 2 oxygens for every carbon. That combination never changes. This is not true in mixtures. Mixtures will vary in composition. You can, and the example here is that coffee is in a mixture, and you can make strong coffee or weak coffee. You can put a lot of sugar in your tea or not very much sugar in your tea, and those are mixtures because their compositions can vary. Pure substances, compositions do not vary. If it's an element, it's composed completely of the same type of atom. If it's a compound, it's composed of 2 or more atoms, but they're chemically combined in fixed ratios. But mixtures vary. Mixtures also come into varieties. We can have homogeneous mixtures. Homogeneous mixtures are things that do not have layers, but appear smooth. Vanilla ice cream. Is a homogeneous mixture. And again, ice cream can vary. You can get it with lots of cream, it's very rich, or you can get it where it doesn't, it's not quite so rich. I'm going to move this over just a little bit. So if something's, the other kind of mixture is a heterogeneous mixture. Heterogeneous mixtures would be things like they're going to have layers, and something maybe like a Payday candy bar. Or Rocky Road ice cream. So heterogeneous things will have layers, and homogeneous things appear homogeneous. They're homo means same, so they appear the same. States and properties of matter. I'm going to barely get this on here. We've got solids. Solids have a fixed volume, meaning it doesn't change. The shape is also fixed for a solid. The particle arrangement is close. So a solid, the arrangement might be like this. The particles may vibrate in space, they may vibrate in place, but they don't slide past each other. Liquids also have a fixed volume. Molecules are touching each other, and so they're not, you're not able to compress a liquid easily. The shape is not fixed, but changeable, and will take the shape of the container. The particle arrangement is touching, but they're able to slide past each other. The particle movement is more than a solid but less than a gas. So more than solid, less than gas. Okay, gases do not have a fixed volume. It's fairly easy to compress or change the volume of a gas. And the shape is also not fixed. Gases will take the shape of the container. The particle arrangement is random and distant. And the movement is very rapid.